Today we are going to tell the Parseval'S inequality or Parseval identity in the Fourier transform. So this Parseval'S identity we also done for that Fourier series. Now today we will discuss about the Parseval'S identity for Fourier transform. Parseval'S identity for Fourier transform. Okay. Suppose we have two functions fx and gx, and for the fx function we know the Fourier transform, and similarly for the function gx we know the Fourier transform. Then so let's write, then let's if let fs cap fx and cap gx be the Fourier transform for the function fx and gx, then Parseval'S identity is saying that fx in gx is equal to 1 by 2 pi fx and gx integration of dx is equal to fs gh ds, and integration range is okay. So it's saying that product of the two function and their integration in the whole range minus infinity to infinity is equal to 1 by 2 pi integration minus infinity to infinity fx and gx. Fs and gs are the Fourier transform for this function fx, and gs is the Fourier transform for the function gx. Okay. Now in particular case, if fx becomes gx, so here remember that here everything fx and gx we are all talking about the real. If it is complex, then suppose something is complex, then we can write like this way. Okay. Now in case that fx and gx are same, so means if fx equal to gx or gx equal to fx, then the above identity becomes okay. So if that two function fx and gx are equal, then if we write in the place of gx as fx bar, then it becomes that fx square, as z bar is equal to z bar square. So use that thing. So here our z is 1 fx and z bar is fx bar, so it's become this one. Okay. So this is the Fourier transform using this Parseval'S identity. Now similarly, if we find out the Fourier identity theorem for sine and cosine transform, we can get another sort of identity. Okay. So let's see what are those two identity. Now we will talk about what is the Parseval'S identity for Fourier sine and cosine transform. Okay. Now let's say that we have the Fourier, let's fc is, so generally we denote the Fourier cosine transform but by taking the suffix of the function fx, and g of c of s be the Fourier cosine transform for the function fx and gx, then Parseval's identity is saying that now integration is 0 to infinity fx gx dx equal to 2 by pi integration 0 to infinity Fourier cosine transform of the function fx into Fourier cosine transform of the function dx. Okay, so this is the Fourier cosine transform. Now sine transform will be the similar. So in the case of sine transform, integration is the same range 0 to infinity fx gx dx. So this is will be equal to 2 by pi integration 0 to infinity f s of s and g s of s ds. Okay, so instead of only that cosine, now it is sine only. Now this Fourier identity will help us to find out so this Fourier transform will help us to find out any type some sort of improper integral. We will now go to that how to find a improper integral using this Fourier transform. Now like that Fourier transform, Parseval's identity for the Fourier transform. Similarly, if here also fx equal to gx, then this equality becomes 0 to infinity fx square dx 2 by pi 0 to infinity Fourier cosine transform of the function fx, that square into ds. Now similarly for this Fourier transform, sine transform, Parseval's identity, so this will becomes the similar type of equality fx dx 2 by pi 0 to infinity Fourier sine transform of the function s ds. Okay.